This video demonstrates the capabilities of our pen plotter for the ME405 Mechatronics class. The system uses polar coordinates using a theta motor and a radial motor with a lead screw to advance the pen, and it can draw an image uploaded to the Nucleo board and has a user interface to select multiple files as well as different modes. I'll start off talking about what we use to create the image. We use Inkscape. You can see here I have a triangle drawn, and this triangle will be drawn later in the video on this piece of paper. So this image is saved as an HPGL, and once it's saved as that, you upload the image to the Nucleo board. You can see it here, triangle HPGL. And when I run the program, we have a user interface with a joystick to select different files. So you can go down to select different files, and then you click the joystick based off what you want. You can see a variety of files are already loaded on here. It automatically does that in the program. It searches for HPGL files, and then you click it to select that file. Before I start this file, I'll demonstrate another feature of this, free draw. So turning on the motors, if I select this, you can see that it changes. It tells us the theta and radial input that I give. Moving to the right changes the theta motor. Let's see if I can get it focused. Changes the theta motor. I can go to the left, and that changes it that way. And up and down changes the radial component. See, I'm moving the pen right now. Move it back. Moving it close to the edge, back to its homing position. You can also click the joystick to activate the solenoid, and this forces the pen down to draw the images. So you can see that it is making contact with it, and I press it again to release, and so you click it and then move the joystick to draw the image that you want, and click it when you're done. So I will cancel the free draw by clicking the blue button on the Nucleo board. That cancels it, and now I am free to select any file that I want. So I will select triangle. Again, you select it by clicking the joystick. This is that the print has started. It'll move it to its origin. There is some axes flipping when you go from Inkscape into the actual motors. It's just how those plotter programs work. So unfortunately it has to move quite a bit to get to what it defines as the origin. You can see that it's starting to draw. You can see that even as it's moving, it's drawing a pretty straight line. Again, it's trying to draw this image. So it's going to start there, then it's going to make a 90-degree turn, and then do the second length of the triangle. I'll take a moment to talk about some of the manufacturing of this. A majority of these components are all 3D printed. So we have all these support and motor supports and holders to hold the motor. Those are all 3D printed materials. I have a variety of set screws on here just to allow for adjustability. Maybe you want to change the height of this roller bearing to help angle it correctly for the pen to make proper contact with the paper. There's also a pen actuator here that I talked about a little while ago, and that uses a solenoid, and when it's activated it forces the pen down. The pen has been modified to have a spring on the end. This is just to ensure that consistent pressure is applied to the paper even with inconsistent board flatness as it's drawing. We can see that it made the proper 90-degree turn. And as it's printing, you can actually see that it demonstrates which of the points that it has successfully printed. So 80 of 131. For this program, it's very important that where you start the print, because where you start it is the homing position, meaning that when it is finished, it will go back to its homing position. So you don't want to start it too far out here because then it won't work properly. So you can see that the solenoid turned off and it moved back to its homing position when it was done. Unfortunately for this particular demonstration, it did not do the triangle correctly. This isn't really anything wrong with the program. These are old borrowed motors from an HP printer, and based off the requirements of it, sometimes it just can't meet it. And so we have a variety of motors here that have to be swapped out just because this motor's too old that the radial component sometimes fails. But when it doesn't, this is the sort of image that it can draw. It could still draw a triangle. So really this is what it was supposed to draw. And you can see that it draws it pretty well. Does that 90-degree turn and then comes back to finish there. So yeah, even though it couldn't complete that, that was just for this particular instance, but it has drawn a triangle successfully before. Maybe if we had different motors, bought the NEMA 17 motors, because this is what we're using for this, and the performance of this is much more consistent. So maybe if we used that, we would have a more consistent and just better drawing capabilities. So once it's done printing, as I said earlier, it homes back to where you started, and then once that's done, you can then select which files that you want again. So you can draw multiple images that you want all in the same. You could select free draw again, and while the print is printing, you can press the blue button as well, and that'll cancel the print and home it as well. I'll demonstrate that shortly. So let's see here. Let's say I wanted to restart the triangle drawing. Oops. So it starts the motor. It's going to start there, and it's printing it. You can see that the solenoid is actuated, and in this case I see, oh, the radial motor is not working. I don't want to use this print because I have to swap out the radial motor. I press the blue button. It cancels it, and it moves back to where it started, so you can sort out your motor issues. With that, this concludes the video demonstration of our pen plotter system. Thank you for watching.